Problem 6-120. Consider the function y equals 3 times the quantity of x plus 2 squared minus 7 as you complete parts A through C below. Letter A. How could you restrict the domain to show half of the graph? Well, as we look at it here, we know that this is going to end up being a parabola, right? Y equals 3 times the quantity of x plus 2 squared minus 7 is a parabola. So if we want to do half the graph on a parabola, you just have to identify what the vertex point is going to be. In this case, our vertex is -2, -7. So I'm going to bring out my calculator here and graph it so you can kind of see what I'm talking about. I've already got it typed in here. So when I graph it, you'll see, get my parabola there. So if I wanted to restrict the domain, so I only had half of my parabola here, okay, when I take it and I restrict it there, I want to start halfway, so I got to start at the vertex. So I got to think about it, everything from this side over to the right. You know what, let's do this. Let's pull this out so we can actually write on it a little bit here. Thank you, Mr. Calculator. Goodbye. So if I wanted to restrict the domain, I could look at my vertex here, right? My vertex here. So my vertex is at the point -2. So this side of my parabola contains all points that are greater than or equal to -2. And which means that this side would be then x is less than or equal to -2. Right? Because we'd be going over here this way. So it says, how could you restrict the domain to show half of the graph? Well, you take your vertex point and you either make the points greater than the x-coordinate of the vertex, or you take it and you make them less than the x-coordinate of the vertex there. So I guess we should probably write that out here. To restrict the domain, to show half of the graph, or let's say half of the parabola, so then we're going to either say, let x be greater than or equal to the x-coordinate of the vertex, or x could be less than or equal to the x-coordinate of the vertex. Okay, so in this case here, we're talking about it would be x is greater than or equal to -2, or you could use x is less than or equal to -2. And the reason we can do either of them there because there's two halves, and it doesn't tell us which half we want to restrict. So, letter B, find the equation for the inverse function for your half graph. All right, so as we look to create the inverse, let's first create the inverse equation for this entire parabola here. So let's do this here. Let's do letter B here. We're going to have y equals 3 times the quantity of x plus 2 squared minus 7. Remember, there's a couple ways you could do this. You could name off everything that's happening to x in order of operations and then go backwards and undo them. Sometimes you have to be careful though when you have something that's being squared there. The other method is to switch your x and y and then solve it for y again. I'm going to use that method right now. So x equals 3 times y plus 2 squared minus 7. So we just switched x and y. Now let's solve this for y. So let's get rid of our 7 first. Let me move this down a little bit so we're not squeezing everything in. So we've got x plus 7 equals 3 times the quantity of y plus 2 squared. Let's now divide that all by 3. So x plus 7 divided by 3 equals the quantity of y plus 2 squared. Then we're going to need to take the square root of each side. This is where some people get hung up. Don't let it be you. Remember, the square root of the quantity of y plus 2 squared is the absolute value of y plus 2. And we've got the square root of x plus 7 over 3. This would then lead to the positive or negative version. So we're going to have positive or negative square root of x plus 7 over 3 is going to equal y plus 2. And then let's just get rid of the 2 there. So we could say negative 2 plus or minus the square root of x plus 7 over 3. And that's the whole entire thing there. Make sure that radical extends to the bottom. Equals y. Or you could put your all of this minus 2 as well. It's up to you. It doesn't matter. So this is the equation of the inverse for both of them. Okay, this is for both. Now, if we were looking at our graph here that we had here again, we've got this side has our restriction of x is greater than or equal to negative 2. So if we're going to say this side, the equation y equals 3 times the quantity of x plus 2 squared minus 7. This one has the domain as long as x is greater than or equal to negative 2. Well, when we take this here, and remember when you graph your inverse, right, it's going to be a reflection over the line y equals x. So that line would end up being through here. So we would end up with a point there that, let's see, 1, 2, 3, 4, 5, 6, 7. We'd end up with a vertex that would be right about here. One of them would be going up and one of them would be going out this way. So it's going to kind of look something like that. It's not drawn perfectly. I'm just kind of sketching it in there. So remember, the positive one here, the positive one is going to end up being this one. That actually probably should have intersected here, my mistake, but this positive one on top will be the one here, because these are the ones that are closer to that line of symmetry, and then the other one here would be the one that's farther away from it. So in this case here, if we said negative 2 plus the square root of x plus 7 over 3 equals y, that is the equation for this one. So this is the inverse for the one with this domain. If you do the other one here with x is less than or equal to negative 2, still has the same equation there. And we're going to have the domain is x is less than or equal to negative 2, which means then that the equation for this one would be negative 2 minus the square root of x plus 7 all over 3 equals y. This is the inverse for this one. Okay, remember, because this is not a function, it needs to be written as two functions because it is not a function. For every input, there is more than one output. So it says, what are the domain and range for the inverse function? Well, remember, if you know the domain and range for your original functions, you can just take them and flip them. So let's see here. For our blue one, let me get this black one out of the way here so we can read it. Let's just set it aside or delete it here for a second. If we need to draw it back in, we can. Okay, remember that point is right there though. So our domain for our original up here, and we'll do that in red up here. So our domain for this one, actually this is the domain, right? This is our domain for our regular function. The range, well, this is the lowest point here at -7, so the range is going to be y is greater than or equal to -7. That is our range. On this side, this is our domain already. Our range, think about it, well, it's going to be the same as this one, isn't it? Y is greater than or equal to -7. Now our domains for our inverses here, think about if it starts at this point and it goes out this direction and goes out this direction, okay, our lowest x value is going to be -7. So our domain for each of them, depending on which one you chose to do, is going to be x is greater than or equal to -7. This is, remember, for part C here. Our range, well, for our top one here, we're starting at -7, -2. So we've gone down to, we're starting here, and remember it's going up. So our range is going to be y is greater than or equal to -2, which makes sense because that's what our domain is in the inverse. And for this one, it'd be going down from -2, so just like our domain was for its inverse, so we're going to say y is less than or equal to -2. And there's your answer. This is part C. That says C, by the way. All right, so this is problem 6-120. Hopefully this helped you with any questions you had. If you have other questions, make sure you get help from your teacher or go visit Math Help. Thanks for watching.